So in order to set this project up, we first had a mouse and a keyboard and we plugged it into the USB slots on the Raspberry Pi. And then you also need this G-mouse GPS tracker or logger, and you plug that in as well. And we had the Wi-Fi extender that we also plugged into this Raspberry Pi as well to help with the connection. And then we had to buy the adapter that had the micro HDMI for this, and then had to plug into our monitor. And that's how we ended up doing all the coding and getting everything started. And then once we took it into the car, we were having trouble trying to get everything, the remote desktop working so we could take it in there with the connection. And so we ended up not even using the mouse and keyboard, and we just powered it with a USB to USB-C through our laptop like it was charging this. And then we ended up taking all the data and going around the neighborhood and getting all of our GPS information.
So we're connecting our Raspberry Pi with a data logger on it to a remote desktop so that we can view the PC screen.
One eternity later.
And now we're going to test and make sure that the Raspberry Pi is collecting GPS data, which you can see right here that we're getting a speed and changes, sort of. So we're good to go on that. And now we're going to actually start logging it with the CSV file. CSV data. Alright, here we go. Alright, now that we have the GPS logger running, it will be taking a speed calculation from our GPS data, and it will be writing it into a CSV folder, which will be recorded, and then we can perform analysis on the data that we collect from our nice little drive around the neighborhood.
We used the map on the right to outline the route that was taken throughout the neighborhood with the different symbols designating key points in the data. So the graph represents time on the x-axis and the speed on the y-axis. The different peaks in the graph show the highest points of acceleration with notable points that correlate to a speed bump, slowing to pass a parked car, and anticipating a wrong turn. So all of those are represented here in correlation to both the display of data points and the significance of where it's represented on the map. And that's how we made sense of our squiggly lines.